Hello everyone, welcome to this new session of CFA Level 2. Today we'll be going over the next reading in our quants curriculum, which is big data projects. Now, as I said in the previous reading itself, which was machine learning, that these two readings, machine learning and big data projects, these are relatively newer additions to your syllabus so that you are aware of all the advancements that are happening in the field of financial technology. So as such, the same applies to this reading also, that the intention is not for you to become experts at data analysis. No. The idea is you should have a basic understanding of the same so that if your organization in the future applies these things, you should be aware of those so that you're able to communicate with the engineers and experts of the data analysis. Your job is still to be the financial expert. So just like it was with machine learning chapter, a lot of terms and definitions, you have to be aware of those. So first thing that we have to understand is what exactly is big data. Well, by the name of it, big data implies very large amount of data. But in a more technical sense, just the volume is not enough. Big data is defined by a few characteristics. Of course, volume is one. So the amount of data is definitely one thing that is relevant. So volume is one key characteristic. But then you also have variety, which means data picked from various sources. The data cannot be from just one singular source. We pick data from multiple sources and a large amount of data. And also velocity. Velocity simply means the speed at which the data is being generated. For example, if I wanted to take stock price information, stock prices update themselves in real time every single second. So if I take price of every single second, that would be a large amount of data picked up from various sources. I might pick few companies from Indian stock exchanges, few from US stock exchanges, from few from European stock exchanges. So I have volume, I have variety, and the velocity, the speed at which new data is being generated in the real world is very fast. So the speed at which data is being created is fast. These three things together form the big data. There is also a fourth characteristic which is called validity or veracity. Just two different names for the same thing. This is used mostly for the decision making side of things, not for the analysis side of things, but for decision making, for inferential analysis. So in those cases, we can also have this fourth characteristic, but normally first three make up big data. Now, from here on onwards, I will be following a slightly different sequence with this chapter. The curriculum is giving readings in a more textual sense in a particular sequence. I'll be taking the discussion in a slightly different sequence so that it is easier for you to remember all the concepts given in this chapter. So for you also, what I would suggest is throughout this session, at least the first part of this session, we'll be making a flow chart, and that flow chart would cover everything there is about the big data analysis. So I would also suggest, along with the session itself, keep making the flow chart, making additions to it, and by the end of the flow chart, big data analysis would be clear to you. Once the analysis part is clear, the last discussion is simply about how exactly do we check the performance of our model. So that is one separate discussion we'll have at the end, but the remaining chapter is just the process elaborated as to how we do the big data analysis. So big data analysis, by its very nature, has a few steps involved. So the first step of big data is conceptualizing. Now, if we go back to our discussion in FRA, over there we looked at the steps of financial reporting analysis, where the first step was to identify the objective and context of analysis. Conceptualizing is the exact same thing. Basically, the idea is what is the context, what is the objective for you doing the analysis of a large volume of data. That is conceptualizing. Once you figure out the objective and context of your analysis, according to that, you would then move on to data collection. So first figure out the context of analysis, then move on to data collection. Now the discussion from this point on, you have about 5 steps. First 2 steps done, very easy. From this point on, the discussion splits into 2 parts. You can have two kinds of data. So the data that you've collected can be of two types. It can be structured or unstructured. Structured data is the one that is organized in some particular manner. So balance sheet, income statement, financial statements of the company, they have a particular format. The data is organized in a proper manner. Those are structured data. And the management discussion and analysis, for example, that is text information, that is unstructured. There is no particular format for that. It is pretty much just text for the most part. So your syllabus, because in finance we are mostly dealing with two kinds of data. One is the financial reports and the other is the text part. The financial reports are structured and text is unstructured. So your syllabus will use these terms data and text interchangeably in place of structured and unstructured. So both the terms are used. Unstructured means text analysis, structured means data analysis. So just be aware of that. Now, one more thing, as I said, we'll be taking a slightly different approach to this topic, mainly so that it's easier for you to understand. In your syllabus, the differentiation of structured and unstructured has been done from the very first point, and then they have created a data steps and then steps for the text part. The good thing is, or rather the reason why I prefer to do it this way is because the first two steps are common across both. So instead of you having to treat this topic as sort of two topics and then study them separately, combining them in one single structure would also give you an idea of how much similar both the things are. After this, we move on to the third step. The third step, in terms of the name at least, so that it's easier for you to remember, is exactly same. It is data cleansing and wrangling. And on this side, it is text cleansing and wrangling. Keep in mind, this step is also called data or text preparation. So basically, we have collected the data. Now we are preparing it for it to be analyzed. So basically, all the data was collected, but it is possible, if I look at this side first, it is possible that out of the data collected, there is some error values. There is some wrong data also. I want to remove that. So that is data cleansing, the act of removing any erroneous data that you might have. Data wrangling, on the other side, is slightly more nuanced. Data cleansing is just removing erroneous data, but data wrangling is more focused on elimination of data due to some specific reasons, not because the data is wrong, but maybe because the data is not suitable for my analysis. So one of the common examples is that at times dates are given for month, dates, and years. But if I'm doing an international comparison, in US, the structure of quoting a date is month, day, and then year. But in India, the structure is day, month, year. So before I do analysis of two companies, one from India, one from US, I first want to do the conversion so that both of these dates come on the same standard. So things like these, when I'm making slight tweaks to the data is now correct. I'm making slight tweaks. Maybe I'm aggregating a few values which are of similar nature, which are correlated. I'm selecting a few features. Features, if you remember from machine learning, features are independent variable. So all of those things are part of data wrangling. So data cleansing is simply removing the error issues. Wrangling is then further tweaking or enhancing the data so that it is going to give better results. The same thing happens for text as well. Data cleansing is the act of removing some of the things that you and I, with our study of English, we understand. But the computer programs would not be able to understand. For example, white spaces. We know from our understanding of English that after a paragraph ends, we leave a little space before we start the next one. But the computer program might read that as something different. So we have to remove some of those things to make the data more suitable for analysis by the computer programs. Maybe removing punctuation marks, because sometimes it could happen that if you have been using computers recently, what we use right now as emojis were first a combination of punctuation marks. So what meaning we have for punctuation in English language might be different from how the computer interprets it. So any of those things, those would be text cleansing, that I'm removing all the issues that might appear, all the things that are not relevant for my analysis. And then text wrangling is simply, now that I have all of the text information, I want to further fine tune it. So what I'll do is I'll lowercase everything, because computer might make a distinction between something starting with a capital letter. We know in English every new word, every new sentence has to start with a capital letter, but the computer program might not be aware of those. So lowercasing everything, or maybe removing the importance of some of the words, so outright removing some common words, for example, a, the, in, of, at, all of these words that outright don't have any financial meaning by themselves. These are just words we use to fill in the language. So these are not of analysis. I will remove that in the wrangling process. Another thing we often do is stemming and also lemmatization. Both of these are very similar in the sense that what we try to achieve is that there can be different terms that can be used. For example, consolidate, consolidation, consolidating. All of these things might appear at different points throughout my text data, but they all mean the same thing. So instead of my computer program picking them as three different terms, I want to ensure that the computer understands all three as same, so that the meaning of the analysis would come out even better. Because if all three are different terms, the computer program would assign different identities to all three, and then the analysis would treat them as three different things. Whereas we know, as humans who understand finance and English also, that all three things would be used probably in the same context in terms of the financial statements. So we can do those things also. Those are called stemming and lemmatization. So that is the third step: data cleansing and wrangling for data, for text. So remembering the steps, the name of the step is exactly same. One is used for data, the other is for text, but what we do inside them is different. That is why I created separate graphs. Now, within both of data cleansing and wrangling and text cleansing and wrangling, you do have some other terms given also which are helpful, which you should know the meaning of. So in data cleansing and wrangling particularly, often once we have the entire data, we've done the wrangling portion as well, we've created a more fine-tuned version of the data itself that would then be analyzed. We can also make further adjustments within this wrangling process. One of those is that at times data might have outliers. So I don't want outliers to influence my analysis too much. So what we often end up doing is that in the entire data, we remove some of the most extreme values. So mean is there, and then we take a certain amount of deviation. Only till that deviation we should have the data. Any outliers which are too extreme, just remove them from the analysis. That is called trimming. Another way of achieving that is called standardization or normalization, where I look at the volatility of my entire data. So if you remember in quants, we had an equation like this. This was for standard error. We can do something similar for data as well, that I want to see how volatile my data is. So I standardize the data in terms of its standard deviation. So we take standard deviation or standard error in the denominator to see how much variation is my data normally showing. Is it showing too much in comparison to what my standard deviation is, or is it within acceptable bounds? So we can also use normalization, where basically the idea is same. Normalization also does the same thing. Instead of using standard deviation as a comparative benchmark, normalization uses the range of the data. So the maximum minus minimum, that is in the denominator. But both of them are trying to judge the volatility of my data set. On the text side of things, normally what we do is we have a tokenization method, where basically what you and I in English language call words, the computer program takes them as tokens. And then each unique word, each word by itself, and then each word becomes a token by itself, and then the analysis is performed on those tokens. So just be aware of these terminologies, because the next step, the fourth step, would have these terminologies. So the fourth step is data exploration. Once again, the name is pretty much same both ways, but what we'll do within the step is going to be different. So data exploration, the idea is simple, that I now have a data that can be analyzed. So first, before I begin the analysis, I want to further look at the data sets and see, is there any characteristics about the data that I should be aware of, so that I can then perform the analysis, I can then tune my computer programs to make better use of this data. So any characteristics I should be aware of, any features that I can select outright from the data. For example, you have company credit analysis that you're doing. For credit analysis, we need something like an interest coverage ratio. So I might be focused on operating profits. So selecting feature set of operating profits is important. So selecting features, selecting independent variables, that is part of data exploration. And sometimes we often do what is called feature engineering, where outright there might be different features. I combine them to represent one feature. So at machine learning reading also we discussed this briefly, that sometimes different independent variables, different features might be correlated. So I combine them into one common feature. So all of that is part of data exploration. One of the things that we often use in data exploration is the principal component analysis. Again, repeating from machine learning itself, where basically I want to look at only those relevant features which would enhance my predictive capabilities of the model. Not all of those, but only the relevant ones. So we can often use PC analysis to sort of eliminate any of the non-relevant features. The same thing can be done for the text data as well, where once again the idea is to understand the data sets a lot more and then select features and make some modifications accordingly. So one of the common things that is done in text exploration is that we create what is called a word cloud. Basically, imagine the MD&A of any company, all the text there is. The computer program has picked up everything. Cleansing has been done, wrangling has been done. So now things are together. Now, what word cloud does is that all the tokens, all the words that are there left after cleansing and wrangling, all of those will be represented in a giant circle or some sort of in a giant circle or any sort of shape. And whichever word repeats more often, that would be in a larger font. And the words that don't repeat, they would be in the smaller font. So outright, it gives you an idea of what words are repeating most often in the entire sort of text data set you have. And that gives you a clue as to what are the relevant things. For example, sometimes for any company's MD&A, company's own name would appear a lot of times. So that is a common thing. The regulators, Ministry of Corporate Affairs or SEBI might appear, SEC might appear for US companies. Those are also common things. Recently, we've had a pandemic, so MD&A would probably have a lot of discussion about COVID. So COVID is a term that might appear a lot. However, if there is a particular expansion project that was given some name and that name is appearing too often, it means that we should further analyze the entire MD&A because that expansion is being discussed about a lot. So all of those things are relevant, and that is the importance of text exploration and the word clouds. We can also make a lot of other adjustments. For example, 4-digit numbers would often represent years. So we tell the computer program that, okay, these values would most often be years. There can also be a lot of elements where the terms should not be used in isolation. For example, the word balance sheet. If I let the computer program split it into two separate terms, balance and sheet, it will lose its value. So outright, there are some terms in finance and in economics that we want combined together because only combined do they have meaning. Income and statement separately don't have the same meaning as income statement together. So I want some terminologies to stay together. So over there, I would also make exceptions in the computer programs that some words should not be separated. They would always be together. This is called the N grams, N standing for number of terms, that how many terms combined make a proper meaning. You can also have parts of speech that you can analyze, that how many words are nouns, adjectives, all of those things. You can also have name recognitions where names are assigned. So if there's a country's name, that would be assigned a place. If there's a company's name, that becomes an organization. So names can also be assigned to which entity they relate to. Is this name of country where the operations are, or is this the name of a company that is a subsidiary, or any such things? All of those things can be done in text exploration. The last step of the analysis is common for both structured and unstructured data, that is model training and evaluation. So here in this step, we would finally move on to the analysis side of things. So far we have looked at data, we've analyzed it briefly, some characteristics, selected features, everything is done. The data side of things is done. Now I'm looking at creating a analysis model itself. Everything you covered in the previous reading of machine learning, that entire content of knowledge, that creates a model. So whatever model you make, everything you studied on machine learning is applicable here. So creating a model that would be able to best analyze the data that I finally have after the exploration step, that is the fifth step. So I have to create a model, and this one exactly a recap of your previous reading. So first thing is deciding whether you want to use supervised or unsupervised learning for your computer programs to analyze the data. Within those, do you want classification done separately? So in that case, you would use cart model or support vector machines, or you directly want to move to some sort of decision tree criteria. So classification required or not. Every single thing that we covered in the previous reading, all of that comes out in this last step, that we create a model. And once we have created the model, then we have to test it in out of sample data. So all the data we use to create the model, now we will try to test it using some data which is not part of this initial inputs. If the model is successful there, then we can deploy it in the real world. If it is not successful, we would require some tuning. So the evaluation part actually is divided into two steps. Firstly, it is performance evaluation, seeing how good the model actually ended up being. So we've created the model to use all the text analysis. How good did it actually turn out to be? For that, we have certain calculations that we often use. For performance evaluation specifically, we have three parameters given: error analysis, receiver operating characteristics, and lastly, you have root of mean squared errors. Now, this is something that we've already covered in regression. This is simply predicted value minus actual value. So whatever the error term is, that squared and mean of it with the root. So predicted minus actual square and root sum. This is something that we've already done at regression. So the mean square error, that, and we just do an under root of that to give us an idea of the volatility that we are dealing with. What are the errors and how many of those errors are probably going to impact my data analysis. If the volatility comes out as too big, probably I need some corrections. So this is the relatively basic part. The new part for you would be A and B, and these also just by the name they are new, because both of these are based on what we call confusion metrics. Outright, the name is not very encouraging for students. However, if you remember level 1, quants, hypothesis, I know you all hate it, but if you try to go back to it, we had a discussion over there. You had a discussion about type 1 errors and type 2 errors, that your analysis, so predictions, could be of, let's take the same example that your syllabus also takes, which is about credit default. So maybe I'm doing an entire analysis to predict default of a company. So the prediction is default and no default, and actually company can commit a default or no default. So basically what actually happened and what my data and my computer models predicted. If actually default happens and my model also predicted that default would happen, this is called true positive. This is good. I want this. If actually my model predicted that no, company will not default, and also company did not default, that is also good. This is called true negative. These are the two good ones. The problem lies where model predicted that the company would default, but the company did not default. This is called false positive. What you studied at level 1 as type 1 error. And if the model predicts that the company will not default, but the company actually ends up committing a credit default, that is a false negative, type 2. Once you look at this entire matrix, now things start to recall a little bit from level 1, and now this confusion matrix doesn't look as confusing. The entire concept of these first two is based on analyzing this itself. So you have certain parameters, you have details like precision and recall. Precision is saying that out of all the model's predictions about default, which means out of all defaults, how many were correct? That is precision. And then you have something called recall, which looks at my model in retrospect. So it says that out of all the companies that actually defaulted, how many were actually predicted to default by my model. So as such, you can have precision where I'm judging just the model by itself, how correct it was out of all the predictions of default. You can also have recall where we look at the model in retrospect, that after I have actual data, how much was actually predicted correctly by my model. You can also have accuracy. Accuracy is simply true positive plus true negative. So correct values divided by all the values. That would be the accuracy of the model, because eventually this is also good and this is also good. So you have these calculations where we focus on how accurate my model is. You can also have an harmonic mean, which is called the F1 score. So all of these things, the harmonic mean of precision and recall becomes the F1 score. Keep in mind, in all of these situations, you could get calculations. Calculations would be of the nature where the values in these boxes are already known to you. You just have to plug them in. So knowing that what precision is, what recall is, what accuracy is, knowing the definition, knowing the meaning of these things, that is important. Precision is, if I give you formulas, precision is true positive divided by true positive plus false positive. So out of all defaults, how many were predicted correctly? Recall is true positive on true positive plus false negative. That in retrospect, out of all the companies that actually committed default, how many were correctly predicted by my model? So precision and recall, two separate parameters. Accuracy is just correct values divided by the total values. That is the error analysis. The receiver operating characteristics, the ROC, this is also using the confusion matrix itself, but instead of looking at some numerical calculations like precision and recall, the ROC focuses mainly on graphical analysis. So instead of looking at some numerical values, it depends on quoting the information of confusion matrix in a graph. So basically, predictions divided by the actual. So you have two parameters given here. You have true positive rate. This is for the receiver operating characteristic. This is for the receiver operating characteristic. So true positive rate is true positive divided by true positive plus false negative. And you have false positive rate, which is false positive divided by false positive plus true negative. Basically, out of all the predictions that my model made, how many were true and how many were false in terms of their respective percentages compared with the actual data. So my actual data is being used to calculate total. So the denominator is actual total. And how many out of those I predicted to be defaults, to be positive. So both of these values would then be quoted on a graph to see what is the gap. If the true positive rate is very supportive of my analysis, that is good. But if the rates come out of a nature where I'm not very confident, the false positive rate is a little too high for my liking, then that is an issue for me. So as such, we look at these in the ROC, where basically instead of looking at just numerical values, we quote these on a graph to see how adding or changing data would impact these things. So we look at them in a graphical manner. That's the only change. Aside from that, the performance evaluation is based on confusion matrix itself. Last step within the evaluation. So evaluation has two parts. First was this performance evaluation. Second element is model tuning. If you remember machine learning, once you create a model, once you analyze it, you figure out that, okay, there is some errors. There can be different kinds of errors. If you remember from previous chapter, variance error, bias error, we want to eliminate that. So what we do after that is we tune the model. Maybe change some feature sets, maybe combine some feature sets, maybe make some alterations. That entire process is called model tuning, also part of evaluation. So basically, this completes your entire chapter of big data. And throughout this, instead of going through the sequence in which curriculum gives the topics, I've tried to do it in this manner itself. What I would suggest to you guys is that this part, note it down at the end. I noted it down above mainly because I didn't want to write everything below. But if you note these things down below, this is an entire chapter in one single graph itself. All this chapter is just focused on is what is big data. You have to remember the three V's: volume, velocity, variety, and also validity if needed. Then conceptualizing is the first step, data collection second step, basic. Then we split into structured and unstructured. We clean the data, we wrangle it, prepare it for the analysis. We further look at the characteristics, select the features, then we train the model. After that, we use the model on an out of sample data, and then we see whether it is performing as required or not. If performance evaluation is good, model can be deployed in the real world. If the analysis or the performance evaluation is not good, it means I have to tune the model, maybe change some feature sets, maybe change some weightages here and there. All of that is our big data projects, the analysis of big data projects. So that completes the entire reading of quants. I hope all of it made sense. Once again, I took it in a sequence and a pattern different from curriculum, but at no point did we skip through anything in particular. So after going through the session, read through it once at least. Trust me, all of it will make sense. You do have few minor terms and definitions. Those you will be comfortable with. So I hope all of this was clear. If you have any doubts or queries, you can always reach out to me, and I hope, as always, you found the session fun and informative. That's it from my side. I'll see you in the next one. Goodbye.